Have you ever watched an incredible home run, a perfect serve, or a mind-blowing sprint and just wondered, how did they do that? Well, it's more than just raw talent or years of practice. There's an invisible engine powering every single great moment in sports. And today, we're going to pop the hood and see exactly how it works. So think about this for a second. You've got a brutal, explosive rugby tackle, then a super delicate, precise golf chip, and then a penalty kick, which is kind of a mix of both. On the surface, they look totally different, right? But believe it or not, they're all run by the exact same fundamental rule. What could possibly connect all three? The answer is force. That's it. Every single thing that happens in sports, and I mean everything, boils down to a simple push or a pull. This is like the secret language of athletics. And in the next few minutes, you and we're going to be speaking it fluently. And this language is pretty simple. It really just has two main words. You've got push forces. Think of a basketball player shooting a free throw, pushing that ball away from their body. Then you've got pull forces, like a rower yanking an oar towards their body to just fly through the water. Push and pull. That's it. That's the foundation for everything else we're about to cover. Okay, so how do we actually use this idea of force? Well, for that, we have to go back to the 17th century and meet a genius named Sir Isaac Newton. His 3 laws of motion are basically the official rule book for sports physics. Let's kick things off with law number 1, the rule of inertia. Now, you've probably heard this quote before, right? But have you ever really thought about what it means on a football field or a basketball court? It's pretty much the law of, well, laziness. Things just want to keep on doing whatever they're already doing, whether that's sitting still or zooming along. And you can see both sides of that coin right here. Over on the left, you've got a football just sitting on the penalty spot. It's not going anywhere. It's perfectly happy staying at rest until some player comes along and applies an outside force, with their foot. On the right, you've got a volleyball that's just been spiked. It's going to keep flying in that same straight line until another force, like the net or another player's hand, gets in its way. Inertia at rest and inertia in motion. Okay, so we get it. We need a force to change what something's doing. But how much force do we need? That's the perfect lead-in to Newton's second law, which actually gives us a little bit of math to connect force with speed. So what does this actually mean? It's simple. The harder you push or pull something, the faster it speeds up. It just makes sense, doesn't it? A professional boxer who can generate a ton of force is going to make that punching bag accelerate way faster than I would. It's a direct relationship. More force, more acceleration. And here's the really cool part. Newton gave us this beautifully simple and seriously powerful formula to figure it all out. Force equals mass times acceleration. You might know it as F equals ma. This little equation, this is the key to putting a real number on the power you see in sports. Now, to use this, we just need to know what each part is. So force, or F, is our push or pull, and we measure that in newtons. Mass, or m, is just how much stuff is in an object. We measure that in kilograms. And acceleration, a, is just how quickly the speed changes. That's measured in meters per second squared. All right, let's put it to the test. Let's say we have a sprinter who weighs 80 kilograms and they explode out of the blocks accelerating at 3 meters per second squared. Using our formula, F equals ma, how much force are their muscles actually generating? Go ahead, take a second and see if you can figure it out. Did you get it? The answer is 240 newtons. It's that simple. We just multiply the mass, 80 kilos, by the acceleration, 3 meters per second squared. And just like that, we can calculate the exact, explosive power of that athlete's start.
Pretty cool, right?
Okay, on to our third and final law, and honestly, this one might be the most mind-bending of them all. This is the law that explains how athletes can seemingly defy gravity and use the world around them to do incredible things. It is all about action and reaction. I'm sure you've heard this one a million times, but in the world of sports, this isn't just some nice philosophical idea, it's a physical reality. It means for every single push or pull an athlete creates, the universe literally pushes or pulls back with the exact same strength. This is the high jumper's secret. So check this out. They aren't just jumping up. What they're really doing is pushing the entire Earth down with, say, 200 newtons of force. And in return, the Earth, because of Law 3, pushes them up with an equal 200 newtons of force. That reaction is what actually launches them up and over the bar. Think about that for a second. They're literally pushing off the planet to fly. So we've got inertia, we've got the force equation,
And we've got action and reaction. 3 separate rules, right? But in sports, they don't work alone. They all come together in this beautiful, perfectly timed dance. So let's look at one final example that ties all 3 laws together: the perfect swimmer's dive.
Let's watch how this all connects in just a split second. First, the swimmer is up on the blocks. Totally still, they're in a state of inertia. That's law 1. Then the buzzer goes off. Their muscles apply force, which causes acceleration off the block. That's law 2. And finally, as they leave, they push back on the blocks. That's the action. And the blocks push them forward. That's the reaction. That's law 3. Boom, boom, boom. Inertia, acceleration, reaction. A perfect physical performance.
So there you have it. This invisible engine of force is absolutely everywhere in sports. It's in the high jump, the swim, the golf swing, the tackle. It's in everything. Now that you know the rules of the game behind the game, I'll just leave you with this question. Who do you think is the true master of force? A massive weightlifter? A nimble gymnast? Maybe even a graceful figure skater? Once you start looking for it, the answer might actually surprise you.